Can you all see the whiteboard?
Yes.
Okay. What answers did you get for the first question? Okay, good. 252 is right. Nidhi or Neil, can you explain?
Okay, so for this, instead of, well, you could have, there are two ways to do it. The first way is adding them up manually, although the way I use a different way. So as an example, 9 plus 8, I'm going to take the first two numbers of the sequence. 9 plus 18 is 27. Now, so you either could have done that, adding normally, or you could have, because it's, if the sequence becomes bigger, it's going to be harder to add. So 9 is 9 times 1, and 18 is 9 times 2. So the answer to 9 plus 18 is going to be 9 times 3, which is 27. So if you apply that logic to the rest of the problem, you'll get 9 times 28, which is 252.
Good. Yep. So if you write this as 9 times 1 plus 9 times 2 up to then 9 times 7, then you can kind of factor out the 9, and you'll get 9 times 1 plus 2 plus 3 up to 7. So this makes the sum much easier. So what is this sum? 1 plus 2 plus 3 up to 7?
28.
Good, 28. And how can you get that easily? Do you have to add it up, or is there an easier way?
Using the counting formula n times n plus 1 over 2.
Good.
Or n minus 1.
Yep. So 1 plus 2 plus 3 up to n is n times n plus 1 over 2. This formula is really helpful here, and in general. So in this case, you can do 9 times 1, 9 times 2, 9 times 3 up to 9 times 7. If you add these up, you get 9 times 1 plus 2 plus 3 up to 7. So using this formula, it's 7 times 8 divided by 2, which is 28. So 9 times 28 gives you 252. Any questions on this? Okay, since we're on these formulas, let's go through a couple of others which are also useful. Does anyone know the formula for 1 squared plus 2 squared plus 3 squared up to n squared? Anyone? So this is n times n plus 1 times 2n plus 1 over 6. This also can be useful if you want to add up squares. And let's go through one more, sum of cubes. 1 cubed plus 2 cubed plus 3 cubed plus so on, up to n cubed. Any ideas for this one? Good, yeah. So it's actually, if I take n times n plus 1 over 2, what the 1 plus 2 plus 3 up to n is, I can just square that. So this is also n squared times n plus 1 squared over 4. Okay, so the sum of squares you can solve with this formula, n times n plus 1 times 2n plus 1 over 6. And then sum of cubes is taking this n times n plus 1 over 2. So basically just the sum of 1 through n, and squaring that gives you the sum of the cubes, which is n squared times n plus 1 squared over 4. Any questions on this? Okay, let's move on to the next question. Okay, good. 3 root 3 over 2 is right. Pawan, can you explain?
Yeah, so since this is a hexagon, if we just make it a line through the middle, and then we make 2 other lines, we can also split it into 6 triangles. So when we do that, we realize that one side of the hexagon is also the same length as one side of the triangle. So we just need to find the height of each equilateral triangle. So doing that, we just use the formula side length times √3 divided by 2. So that's how you get the answer.
Good. Okay, let me just finish drawing this. Okay, so if we start with a hexagon, we can connect these diagonals and we'll see that we can get 6 equilateral triangles here. So if one side length is 3, the side length of, so it's a regular hexagon. So each side length is going to be 3, as well as this is an equilateral triangle. So we know this side and this side is 3. And what we're asked for is this apothem length, which is this. So this becomes the height of an equilateral triangle. With length 3, or side length 3. So there's a few ways of doing this. One is if you know that the side length is s, this should be s times √3/2. Or another way is if you know about 30, 60, 90 triangles, you know that the angle here is 60 degrees of an equilateral triangle. By drawing this height, this angle becomes 30 degrees. So if this is 30 degrees and this is 60 degrees, this is, if whatever this is that times square root of 3. So in this case, this would be half of the length here. So 3/2. So this would be 3/2 times √3 as the height. And so using that, we see that the answer should be 3√3/2. Any questions on this? Okay, so one thing that's interesting, or that's a useful fact to know, is so given the apothem of a regular polygon, how would you use this to find, let's say this has length x, what would be the area of the polygon given its apothem being x? Any ideas? So generally, this apothem is connecting the center to the center of the side. ½ area times the height. That's close. Pawan, can you explain?
I meant to say 1/2 times perimeter times apothem.
Good. Yeah. So you can think about this as for a particular triangle here, right? So if I knew the apothem length and I know the side length, I know the area of this triangle. This area is just the side length times the apothem divided by 2. And I can repeat this for each triangle, right? And if I add up the area of all the triangles, I'll get the area of the figure. And I can do this for any polygon. It didn't need to be a hexagon. If I know the apothem length and I know the side length, I can multiply the apothem length by the side length, divide by 2, and get the area of one triangle. And if I repeat this for each side, I get the area of all the triangles that I divide the polygon into. So in general, the area of the polygon, like Pawan said, should be 1/2 times your perimeter times your apothem length. Or each triangle should be 1/2 times the side length times the apothem. Any questions on this? Okay, let's move on to the last question. Okay, 75 is right. Pavan, can you explain?
So in MATHCOUNTS it has 3 vowels and 7 consonants. So to sort off with the number of ways we can have vowels in the bag, we just do 3 choose 2 because there's a total of 3 vowels, but we only want 2. So there's only a total of 3 vowels that can be in the bag at like 3 combinations. And then for the consonants, there's one case where there's 2 T's. If there's 2 T's as one of the cases, then there's 5 choices because we can have 1 letter for the 3rd choice. And there's another case where there's only 1 T, and since they're indistinguishable, we treat them as only 6 options. So there we can just do 6 choose 3 because we want 3 consonants, and that gets us 20. So adding those 2 numbers up, 5 plus 20 equals 25. And since we want the probability, since they can happen in any order, we do 25 times 3.
Good. Yep. Okay, so the question, let's first so go back and see. So we're asked we want to have 2 vowels and 3 consonants to put in a bag, and how many choices there are for the letters in a bag. So if we look at the letters in MATHCOUNTS, there's 3 vowels, A, O, U. The consonants, we have M, T, H, C, N, T, S. So we can split it into 2 parts. We can first say, okay, how many ways are there to have 2 vowels in the bag? That's an easier question because we're just saying, okay, so it could be either AO, AU, or OU. So there's 3 choices for the vowels that I put in the bag, and that's also just 3 choose 2, which is 3. The trickier part is the consonants part. We want to have 3 consonants in the bag, but the 2 T's are indistinguishable, which means that if I, let's say, had M, T, and H in the bag, I don't care if this T actually was the first T in MATHCOUNTS, the T between the A and H here, or whether this T was between the N and S here. We just care that there's an M, a T, and an H. So if the bag has only at most 1 T, then we could imagine that I didn't have this T at all. So I only had 1, 2, 3, 4, 5, 6 consonants, and I had to choose 3 of them. So 6 choose 3. 6 times 5 times 4 divided by 6, which is 20. So there's 20 ways of choosing 3 consonants if I never had the second T as an option. If I just had M, T, H, C, N, and S, I have 20 ways. But by having the second T, the extra cases it gives me is if I actually have both of these T's. So if I use 2 T's, then I could have MTT or THT or so on. So the number of cases that have both T's is just, I need 1/3 letter. So one of M, H, C, N, or S. So this is with 0 or 1 T. There's a total of 20. And with 2 T's, we have 5 choose 1 or 5. So total options for consonants is 20 plus 5. For vowels is 3. So 3 times 20 plus 5 gives 75. Does this make sense? Any questions on this? Okay, then that's it for today's class. We'll see you all next week.
Bye. Bye.
Thank you.
Thank you.
Bye.